let the final few people grab a seat. My name's Chris Jones of Novalia in the UK. I'll be chairing this afternoon session. And so I guess without much further ado, I'll introduce Maarten Cauwe of the Holst Centre imec to be describing or exploring whether the competitiveness of printed electronics, whether it's really more sustainable than PCBs. Thank you, Maarten.
Thank you, Chris. So my name is indeed Maarten Cauwe. I work for the Center for Microsystems Technology, which is an associated lab of imec. And I made this presentation together with Stephan Harkema from Holst Centre, who is also in the room. I assume this was not a slide you were expecting to see at a printed electronics conference, but I put this in just to tell you that I'm a die-hard PCB guy. So just to know that this is where the story comes from. I've been working on PCB technology, and in the last few years we have been doing that together with the European Space Agency, so high reliability markets. And during one of these projects we also looked into sustainability for electronics for space. And this was my personal introduction a bit to the topic, and also to how to quantify that impact. We've been working together with the Holst Centre, I think, for over 15 years, and I have been standing on the sideline watching the developments of printed electronics. And also today, again, I'm impressed with what is possible, not just in shiny demonstrators, but in real products with real reliability and real performance. So I think printed electronics has come a long way. And printed electronics undoubtedly also has benefits for sustainability. I think inherently it's a technology that typically uses less material in the product itself, so it allows you to reduce weight. Also during production, or let's say the materials itself are typically also less harmful, and printed electronics can replace multiple PCBs, so in that sense also saves environmental impact. Manufacturing processes themselves, they're using materials, typically thermoplastic materials, so these are inherently recyclable. Most processes are low temperature initially, or it still is somewhat of a restriction, but actually for environmental impact it helps, because the less temperature, the lower the temperature, the less energy you need. The technology is also compatible with renewable polymers, so bio-based materials. It's typically additive manufacturing, so again less material, and you also use less hazardous metals and chemicals during the production. Recycling of electronics in general is a tricky topic, but also there printed electronics, if they're ending up in the proper recycling chains, would lead to less incineration or less landfill of electronics. And also there, as mentioned before, it would be compatible with compostable materials. Now there's ample evidence out there comparing PCBs to printed electronics, and this is an example of an LED lighting foil, so flexible lighting foil that Holst Centre developed together with Signify, and ITEEN did an LCA analysis showing that the hybrid and printed electronic version already reduces CO2 emissions by 56%. And there are further developments on the way that will be presented by Corne Rentrup at LOPEC. So this shows that there's a big improvement possible for printed electronics. Another example from Tactotech showing an in-mold electronic version, again by removing the PCB that in there, they can strongly reduce the impact both during production as during use.